Hello everyone, welcome to my YouTube channel. This is a infinite chemistry and we will discussing the series of the modern method of organic synthesis. This is my lecture number 5 and we will discuss about the more important question for the CSIR NET and GATE exams. So in this series I will discuss a new reaction. This is your reaction. Then see, this is your reaction. In this you are given a cycloketone at here, and here mention a reagent. The first step in reagent given a NaOET with ETOH, and first step in you have a COOET ka whole twice, and in a second step further give a NaOET and ETOH with MEI, and third step have given in a HCl with heat or LDA. This is your reaction from this book, and the number of reaction is your 1.15. This is a chapter number 1. Chapter 1 reaction. This is reaction number 1.5. And in this reaction you will discuss about the reaction. See, you are given a compound is cycloketone hexanon, and here also mention NaOET with ETOH, and firstly there is a ETOH is a solvent and NaOET your base, NaOET your base, okay, and as well as a nucleophile, because this is having a tendency to attack direct as a nucleophile at the position, and also behave as a base because this is abstract the hydrogen, a more acidic hydrogen, abstraction of acidic hydrogen. See, there is a ketone, but this ketone is a symmetric ketone. This ketone is your symmetric ketone. Here is a symmetric ketone. This is your symmetric ketone, and not mentioned is see, here is a 4 hydrogen, 2 hydrogen at here, and this is 2 hydrogen. Both side is a hydrogen is equally acidic, so I will remove anyone from here. So I will remove firstly your ketone, and there your hydrogen remove by the base NaOET. There is nucleophile and attack this position, and this generating ion at this position. See, in the next step we have this is carbon nucleophile, and as well as we can draw it is also this negative charge with delocalization with carbonyl, and this is your oxygen nucleophile. This is your carbon nucleophile of enolate, and this is your oxygen nucleophile of enolate. Okay, both are possible in the reaction, and in the next step we have in the next step what we'll get? In the next step we have a COOET whole twice, and in the next step we have a COOET all twice. This is your electrophile. See, I will openly show it here. Then you are simply understand with this. Your reagent, sorry, there your substrate, and here this oxygen negative charge are pushing in this side, and this carbon nucleophile will attack at this position of carbon, and this negative charge will be delocalized with, and there is a OET is a good leaving group, so this is your remove from this position. And the next step we see, there is your carbonyl group, and there is new bond forming in this carbon and this carbon. So here is your double bond OET, and remove in this step your ETO negative, here remove. Now in the, this is your product A from the first step. Okay, this is your complete your first step. In the next step further, given a NaOET with ETOH. See, this is your base as well as a nucleophile, and have a tendency to the remove more acidic hydrogen. Which hydrogen is removed? More acidic hydrogen. More acidic hydrogen remove. See, in this substrate further have a 1 hydrogen at this position and 2 hydrogen at this position. Always and always remember in your mind, if any hydrogen with present at the position of alpha to electron withdrawing group, then the possibility of the hydrogen is a more acidic. If I will say that any one hydrogen is present to the alpha of any electron withdrawing group, this is a more acidic hydrogen. This hydrogen is a more acidic. See, these both hydrogen are conjugate with only one carbonyl group, and another in this hydrogen is a conjugate with both electron withdrawing group. So the possibility of more acidity of this hydrogen. So in the next step, NaOET remove the hydrogen is that this hydrogen will be removed from here. This hydrogen can remove, and there is generating a nucleophilic site. I will draw. Okay, I will draw it here. There your carbonyl, and here is your NaOET, and here is your nucleophile. This nucleophile will be delocalized with this oxygen, and another one is this oxygen also delocalized. Okay, in the next step we will also draw the another intermediate structure, is that there is a double bond O negative at here and OET get at here, and there is your carbonyl. This further this oxygen nucleophile is attached to here, this double bond comes to it here, and this oxygen get to negative charge. In the next step also possible, and there is your intermediate, and in the next step we will have a next step in a we will get a In the next step we have a MEI. See here, this is your nucleophile, and this negative charge of oxygen can delocalized with conjugate with this double bond, and this carbon nucleophile will attack this Me, and this is pushed outside, and forming there is a SN2 type reaction is possible with Me. And in the next step is we will have a C double bond O ET, and here is Mi will be inserted. See, here is a stereo will be not mentioned because possibility of the attack from the front and back both side is possible, because this is a planar in the ring, this is a alkene, and this is a planar with a ring, so possibility of the stereo is not mentioned. Okay, both are possible at here from back and front both sides. And in a next step is you're given HCl as well as heat, and there is a decarboxylation is possible in the reaction. Then we can remove from here is a CO2, and we will get a final product of the reaction is C double bond O, and Me will be inserted is here, and this group will also remove from here through the decarboxylation, and this is your final product. There is product, the given of the lot of reagent, and see, this is your final product, and how to this is the final product will be formed, and why this reaction is given in the book. First, your symmetric ketone to, this is your symmetric ketone. Okay, this is your symmetric ketone to unsymmetric ketone formation reaction. This is unsymmetric ketone formation reaction. This is your why this reaction is given in the book. This is a symmetric ketone to unsymmetric ketone is a formation reaction that is, and there is a given a reagent, particularly this is NaOH. By the use of NaOH with ETOH and another substrate to use, by the using that one of the way which we can form a unsymmetric ketone. Thank you so much for watching my video. If you like, then share the video. Thank you so much.